Okay. So today we'll start. What is the name of today's topic? Is Newton laws of motion. So before I start, I want to ask some question all of you. Okay. In kinematics, like before in previous chapter, what we have learned in previous chapter, that is all about kinematics. In kinematics, what we have learned? We learned that how objects are moving. Studied quantities like displacement, velocity, acceleration. So one more question was left unanswered. So why does an object start moving? Why does it stop? And what causes acceleration? Kinematics describes your motion but does not explain the cause of motion. Understand? So to understand the cause behind motion, we now move a new chapter that is called Newton laws of motion. In simple word, we can say kinematics is equal to how motion happens. In NLM, equal to why motion happens. So let me ask you one more question. If a ball is lying on the ground, will it start moving on its own? If why or why not? So in the chapter we'll answer all the question I have asked before. Okay. So I will discuss what is force. Force is nothing but a push or pull acting on an object. You understand? Force is nothing but a push or pull. Okay? Acting on an object resulting from its interaction with another object. Okay? And it is an external agent that can change or tend to change the state of rest or motion of body. Means simply we can say force is like change the state of the body. If somebody state change, that means state change of body. If some body some object is in rest, if we apply force, then it will be in motion. If some so the transaction is there na, from rest to motion. So before it was in rest. After applying the force, it's changing the state. Now what is the state? It's motion. Okay. Or also it can be opposite. If someone is some object in motion, we apply force to stop it, to become it rest. Okay. Now what is the SI unit of force? It is Newton. So Newton laws of motion, Newton. Okay. And we denote force equal to F denoted force. Okay. And one more thing, force is a vector of quantity. That's why I use this arrow. Okay. Next we'll discuss like what is the effects of force. Effects of force means like the change of state, like moving a stationary object, stop moving object, like your friend is riding in a bicycle, you applied force, or like you pulling the bike to stop it. Okay? Like change the speed, like if you're riding a bike or cycle, you pedal or you giving more accelerated your bike or cycle to increase your speed. Uh, Also like change direction of motion. Like if you're in cycle, you apply brake or some force to like change your direction. Right? That kind of force we have effects is there. Next is types of forces. Mostly there are like two types and we'll discuss. One is contact. Another is non-contact forces. Okay. So what is contact and non-contact forces? So in contact we can say that the forces which arise due to physical contact between two objects. Okay. So due to physical contact, so it can say that these forces can act from a distance. Act from a distance. Okay. Cannot act. This force cannot act from a distance. If the objects are to have like long distance between them, if they are not contacted, then we can say there will be no forces. Contact forces will be not there. Okay. Force is exerted only when the objects are touching. Okay. Next is, so what is the example? Friction is there. Okay. Friction opposes motion. Okay, we will discuss what is friction. Now we only know the friction always will acting opposite of the motion. Okay. Next, friction, after that normal force. Normal, then thereafter tension. Okay. Next there is spring forces. Okay. These all are in the contact forces. So I think you all understand. Now we have discussed what is non-contact forces. So what is non-contact forces? From that name you can understand like forces that act without any physical contact between two objects, and there will be no physical contact. These forces can act from a distance. Okay, they will like in contact forces they will never act from a distance, but in non-contact forces they can be act from a distance. They are also called action at a distance forces. Okay, now we see what are the example of the non-contact forces. That is in the gravitational forces. You all heard this name. Okay. In next two chapter we will discuss what is gravitational forces. Before there is electrostatics. It's in 12. We will discuss in 12. Okay. And one another is magnetic force. So all these are non-contact force. But in our chapter we will mostly focus on the contact forces. Okay. Friction, normal, tension, spring. Okay. Next, one more types are in forces. One that is like balance forces and unbalanced forces. So what is balance force? Balance force nothing but it is like two or more forces acting on an object that are equal in magnitude but opposite in direction. Okay. So like you see that this object in box, we applied 10 Newton from this side and also 10 Newton from this. So if there will be any movement, no, there will be no movement because we applied same forces but in different directions. Okay, so there will be net resultant of the force object will be zero. That is called balance force. Or because of balance force, there will be no change in the object's state. Okay, Uh, if some body is in rest, object in rest, it will be rest. Always it will rest, or some object in motion, it will always be motion because if we apply balance force, there will be no movement, no change, and the objects remain at rest or continues to move at a constant speed. Like a book, like you see some your books are in the tables. They are always in the books. Always will be in the tables. If you do not pick up or move the books. Okay. Then there is second one is unbalanced force. So what is unbalanced force? It will be like opposite. Okay, nothing more than that. Unbalanced force occurs when the forces acting on an object are not equal in magnitude and or direction. The net force is not zero. The net force will be not zero. So you see here we applied 10 Newton and from this side I applied 50 Newton. So which side the object will be moving? The object will be moving this side because the forces from the right to left side that is bigger than the right to then left to right side. Okay, so unbalanced force, what is the effect of unbalance? Because of unbalanced force, there is the change in state of motion. Right? Like there will be like big deceleration, acceleration, change in direction, starting, stopping movement. All the things are because of unbalanced forces. So the object will move in the direction of the greater force. Okay, one more thing. In like there's a greater force when the 15 Newton applied, so this side will be the object is moving. Next we will discuss Newton laws of motion. So before we will discuss Newton law of motion, there one important topic that we have to discuss, that is inertia. So what is inertia? Inertia is a very interesting thing. Like inertia is a natural tendency of objects to resist any change in their state of rest or motion. Means like inertia is a natural tendency. If some object is in rest, it's always try to be in rest. If some object is in motion, it's always try to be in motion. Okay, that is the natural tendency. Like if you see any car is on the road, if there is no driver, there is no forces applied, that will always be in rest. That is a natural tendency. That is the state of inertia. There are three state of inertia. Okay. One is inertia of rest. Okay. Second one is inertia of motion. And third one is inertia of direction. Okay. These three are the inertia. On one more thing, like inertia always depend on the mass of the object. Mass of the object is proportional to the inertia. Okay, it can help us for solving the question. Like you see any car is there, big truck is there. If you try to change, apply forcing to move, then there will be so much forces applied because this mass is greater, mass is very much. So if you try to like any movement, any cycles, then you have to apply very less force because that mass is very less. So change of inertia will be very less very easily. But in track it is different. So mass is proportional to the inertia. So now we'll entering the Newton laws of motion. So what is the first law described? The first law say that an objects always remain at rest or in uniform motion in a straight line unless acted upon by an external unbalanced force. Okay. Rest or always be in motion. If there is no external unbalanced force. These three things you have to know. External unbalanced force. So it is important. We will discuss earlier what is unbalanced force. Okay. So if F external is 0, then there will be no acceleration. Means we can write F is equal to 0, then acceleration of the object also 0. Okay. Always. So there is some question in it previous year, NET 2020, 2017 now. So what is the question? And question it is asking a short question you can answer from by hearing. Which of the following is an example of inertia in direction? Okay. I'll sharing some ABCD option you have to answer. First one is a person moving forward when a car stops suddenly. Cars stop suddenly. Okay. Next one is a coin falling vertically when the card is flicked horizontally. Coin is there, one card is there. If this side, then coin is inside. Okay. And difficulty is the change of the direction of the fast moving object. If there is a car, fast moving direction. And next last one is a book lying on the table stays at rest. So from the first one we can understand that is the inertia of motion, because first it is on motion, then after applying the brake it suddenly stops. So the upper part of the body of the person is in the motion, but the lower part which is connected to the bus, it is always in the it, like it become rest, but the upper part did not complete in rest, it is in motion. That's why it, when the car stops it move forward suddenly. Okay, next one is coins falling on the when you move the cart so fast, then the coin which is above in the cart, it's in rest of inertia, so it fall down, and that is the state of rest of inertia direction. Okay, that's our answer. And book lying on a table always stay rest, that will be if you apply inertia of rest. One JEE question is asked 2012. The question asks 12. What is the question? The inertia of an object depend on its. So we earlier discussed inertia of object depend on its mass. Understand? So now I think we have clear. Like before, I asked why does a passenger fall forward when a bus suddenly stop? Because of it inertia of motion. Okay. Now coming to the Newton's second law of motion. So before we enter, we'll discuss some important things. That is called momentum. What is momentum? Momentum is a physical quantity that describes the motion of an object. Okay. It is the product of an object mass and velocity. Then write that is the momentum. It is also a vector quantity. Okay. What is the unit? Kilogram per meter. Kilogram per meter per second. That is the unit. And what is the dimension? Dimension will be ml t minus 1. That is the dimension. Okay. So there are in three effects in momentum occur. One is mass effect. Second one is speed effect. So what is mass effect? Mass effect means like heavier body needs more force to start or stop in the same time. You see, any truck is coming from opposite direction. If you try to stop, then you apply so much force because its momentum is so big because of the mass. Okay, and speed like on bullet coming from a gun. To try to stop the bullet, you have to apply so much force because there is speed. Because of speed, the momentum is how very much. Okay. Both the things are important, speed and mass. So one question we'll do. The momentum of question is that the momentum of a body is, what is the momentum of a body is 60 kg meter per second. Okay. If its mass halved and velocity is double, what is the new momentum? So the first momentum is mv. Now in second, what have we done? Mass is half. Okay, m by 2, and velocity will double v into t. So 2 2. You see, there is no change in p and p1. So the momentum will be the same. So what is the before a momentum? 60 kg per meter. Now also the momentum will be 60 kg meter per second. Okay. Now we'll discuss Newton's second law of motion. So what is second law describes? Second law said the rate of change of momentum is of an object is directly proportional to the applied unbalanced force and occurs in the direction of the force. Okay, means the rate of change of momentum of object is equal to the force applied on the object. Means we can write rate of change of momentum dp by dt. Okay, rate of change of momentum. From here I can write t mv by dt. Okay. If mass is constant, you can write dv by dt. F equal to mn. Understand? So from here we got the F equal to mn. It is very famous. So from second we got. Okay. Like kicking a football. The harder you kick, the more the ball will accelerate. Next, next one more question will do. It said that a force produces an acceleration of 2 meter per second square. Force produces an acceleration 2 meter per second square. In a body of mass 3 kg. So what is the mass of the body is 3 kg. And what acceleration will the same force produce in a body of mass 6 kg if we change the m2 equal to 6 kg? Then we have to find the acceleration. So from here F equal to, we can write 2 into 3, that is 6 Newton. Okay. Now the force is same, but we have to find the acceleration. We can write m to a to m to 2 equal to F equal to c, m2 equal to 6. We have to find a equal to 1 meter per second square. So, very easy question. Okay. One bullet question is that. So a bullet of mass what is given 0. We can write mb. Okay. 0.04 kg. Okay. With a speed of 90 meter per second. So what is the velocity of bullet? Speed 90 meter per second. Enters a heavy wooden block and is stopped after a distance of 60 centimeter. So displacement is 60. Change it in meter. 6 meter. Okay. The average resistive force exerted by the block. Okay. On the bullet. So we have to find the average resistive force. So what is in the thing given? Mass and energy. So from here we can write 90 meter per second. Okay. Force equal to required, F equal to mass is given, acceleration is required. So if we can write acceleration equal to v minus u by t, where u means vp. Okay. The last like the blood become last final velocity will be 0 na. Be 0 minus 90 t equal to per centimeter per second when after stop after a distance of 60 centimeter. So what will be the acceleration? T equal to in 1 second. Okay, we'll take t. So we can write mass equal to 0.04 to 90. So that will be the answer of this question. Speed of 90 meter heavy wooden block. First, what have we done? Like, we know the last will be the pole, the last velocity will be 0. Last velocity will be 0. Like, so the final, we also can do one thing like change in momentum mass into velocity. We can do that also then. Change in momentum, like final momentum will be 0. So force equal to, can write now. It's equal to change in momentum. Rate of change in momentum. So first, mm, the final momentum is 0 minus 9. Same thing will become. So you have to apply the acceleration and so we'll see the next question. What is this? A body of mass 2 kg travel according to the law. So it is given that x equal to xt equal to p t plus q t square plus rt cube. Here it is given p equal to 3 meter per second, q equal to 4 meter per second square, and r equal to 5 meter per square. So we'll put the value first. X equal to pt. P, what is the value of p? 3. 3t square. 3 3t square, not 3t. Okay. The q value 4. 4t square. And what is r? 5. 5t. So if you do differentiation, then we will be getting the velocity dx by dt. Then what will be there? 15t square. 8t plus 3. Now if you do dv by dt, you got the 20 plus 8. So it is mentioned that t equal to 2 seconds. T equal to 2 seconds. So 68 Newton force will be required. Okay, very easy question. One bullet question over there. Okay. And said a machine gun fires 10 bullets per second. 10 machine gun. So machine gun will apply 10 bullets per second. Each mass of 50 gram with the velocity. So we convert the mass first. 0.05 kg. And what is the velocity? 300 meter per second. Now, what is the force required to keep the gun in position? So, what is the force required to keep the gun in position? So, from here we can write that the momentum, final momentum is 0. Okay. Now, final momentum, like initial momentum, like we only holding the gun. So, initial momentum can be 0. No? Change in momentum we can write 0 minus 0.05 into 300. Okay. So we get 15. That is our change in momentum. Now to find force. Force from, you can write force equal to rate of change of momentum. Yeah, that is 10 bullets. So 15 into 10 and t equal to 1 second. So what is the answer? 150 Newton. think this question is enough. Okay. Now we'll cover the topic impulse before we go to the third law of Newton's. What is impulse? Impulse is the effect produced when a force acts on an object for a short time interval. Yeah. Like any car hit to some bike or bicycle. So the like the time is very less, but the effect produces so much. Like if your friends slap you, like that time is very less, but the effect produced that is too much. Okay. So impulse, we denoted impulse J equal to force into delta t, that is time duration. Vectors also one, impulse also one vector quantity. Okay. And what is the, it will be unit, force Newton and second. Okay, everything fine. Okay. Now we'll cover one more thing, impulse momentum theorem. What is impulse momentum theorem? Impulse momentum theorem said that impulse of a force acting on an object is equal to change in momentum of the object. So impulse force acting on an object equal to change in momentum of the object. Change in momentum of the object. Okay. So we'll do one question on this. So batsman hits a ball straight direction on the bowler without changing its initial speed. Okay. One ball is hit to the batsman. Initial speed is of the it changes its initial speed. Ball's initial speed is 12 meter per second. Okay. The mass of the ball is 0.15 kg. Now determine the impulse imparted to the ball. Find the impulse imparted to the ball. Okay. So if you take this side equal to like um, mass and velocity, this side is positive. Okay, and this side is negative, velocity negative, and this time positive. Okay. From here we can write change in momentum equal to, we can write mv minus, see, what is 2mv. So what will be the impulse equal to, we know change in momentum. So that's why we're doing 2, 12 and 0.5. Think we will be able to solve this. Okay. Next one more question. A bullet of mass 50 gram. Okay. So convert the bullet mass in SI unit. Okay. 50 gram means 0.05 kg. Fired with the velocity of 100 meter per second. So what is the velocity? 100 meter per second. And come to rest at in 0.02 seconds. Calculate the average retarding force and impulse. To calculate the force and the impulse. Impulse means change in momentum. Okay. The final momentum will be zero, na? That is like final velocity becomes zero, so final momentum will be zero. So our initial momentum is 0.05 into 100. That is minus 5. Now we have to find the force. For force, we equal to required acceleration, mass into acceleration. Mass is there, delta P is there. Okay. Time also given. Okay, rest. Block comes rest in 0.02 seconds. Time is given. So here you can write acceleration equal to v minus u by t. Final velocity is 0, 100 minus 100. T equal to 0.02. From divide we get the acceleration, and after we can apply 0.05 and the acceleration from here we got. Okay, I think we can solve this question. Okay, solve it. Most of the things I have done. Okay. One more thing I will discuss next hour. Law of conservation of momentum. Law of conservation of momentum. Okay. So what is it? The total momentum of an isolated system of interacting practically remains constant. This means the momentum always be constant. The final initial momentum. Okay. Two object to total initial momentum equal to total final momentum. That is same. If we assume two object mass n1 m2. Okay. Two initial velocities u1 and u2, and their final velocity of v1 and v2. So what is said that m1 u1 plus m2 u2 equal to m1 v1 equal to plus m2 v2. Okay. So expression go to AC parameters. So next we will discuss what is Newton's third law of motion. Okay. So what is Newton's third law of motion? Newton's third law of motion states that for every reaction there is equal and opposite reaction. This means that whenever an object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first object. Okay. So then F12 equal to F negative F21. The negative sign will indicates that the forces are equal in magnitude but but opposite in direction. Okay. So what are the key points we have learned here? Action and reaction. Yes, force always occurs in pairs. The force exerted by the first object is matched by force from the second object. Reaction equal in magnitude, but the direction will be opposite. Okay. And simultaneous forces. Action and reaction forces act at the same time, not one after another. Okay. They will act at the same time. And different objects. The action and reaction forces always act on different objects, never on the same object. As these forces are acting on different objects, they do not cancel each other. Okay, like jumping, recoiling arm, walking, swimming. When you walk, your foot pushes backwards on the ground, and when the ground pushes your foot forward, allowing you to move. Swimming, a swimmer pushes water backwards, and the water pushes the swimmer forward. Okay. Then one more concept is there, that is equilibrium of particle. And that will be helping us to solve many questions. The particle is in equilibrium when the net external force is acting on its zero. In this state, the particle either remains rest or move with a constant velocity. That is. Now I will discuss the contact forces we have earlier mentioned. Okay. So what is normal forces? Normal forces is nothing. Normal forces is like nothing more than like is a perpendicular contact force exerted by a surface to support the weight of an object resting on it. Okay. We see there is some table. If the book is there, then the normal force will be okay. Weight is and that is normal. Okay. Acts perpendicular to the surface and balance the component of weight perpendicular to the surface. It can change the depending on the surface inclination of or an acceleration. Okay. Next coming is tension force. Tensile force. So what is tension force? Tension is the pulling of force transmitted about a string or rope, or cable or chain, anything, when it's pulled tight by forces acting from opposite ends. Okay. Tension is like I'm showing some the objects is there. And tension will be occur this side from this side. Okay. That is okay. Always acts along the string, and the direction of tension is away from the body to which the string is connected. Okay. And string, many things like we assume that a string is massless for solving the question, and string is inextensible, means it cannot be stretched, and tension is uniform throughout the string. Okay, there will be never change in the string. Next, one more thing, like if the string is same, then the tension will be same. When the string will be different, then the strength will be also different. Okay, let's see if two objects are there. Okay. Here the tension will be T1, but here the tension will be T2 because the rope is different. Okay. Next, coming to spring forces. So, what is spring force? When a spring is compressed or stretched by an external force, it resists deformation by exerting a restoring force. Means that is the displacement. Before the string was like that. Okay, because of the object, it's there is some displacement. It is it's shown with x. So the spring will act F equal to minus kx. For a small displacement for its natural, the restoring force is proportional to the displacement. Okay. Next are the weight like mg. We have discussed the gravitational force weight. Weight is the like nothing the gravitational force exerted by the earth on an object. It always acts vertically downwards and towards the center of the earth. Okay, if object is there, then this key points. Weight is different from mass. Well, mass is the constant everywhere, but weight changes with g. G when we will study in g or where the places g is different. Okay, that's why weight also will change. It is non-contact forces caused by gravity. Okay, and acts through the center of gravity of the object. Then we come the most important thing from where we start solving the question, like free body diagram. That is will be help like the Ramban. Okay. help to solve any questions without a place. So drawing a bed is essential for analyzing the equilibrium. What its purpose, it helps us to visualize all the forces acting on the pins. Practical. Okay. Steps. What are the steps? First one, isolate the object. Means choose, like we have to choose the object or body, like to study or represent it with a simple shape like a box or dot. Most of this we compare the dot or box. That's the two things we use. Okay. Next, we have to identify all the forces, all the forces acting on the object. Okay. Common forces like gravitational force, we have to show normal, tension, friction. Okay. And draw the force vector. Represent each force by an arrow starting from the object. Okay. And label the forces like clearly. Each like label each other forces with appropriate symbols. And like N is for normal, force mg gravitational, F for friction. Okay. Some example we see. 3 kg, 2 kg. Which is there will be one mg, 2g, 2g, 2g is right. And normal. So 3 kg, two things. One will be this normal acting on it. Okay. And from Earth there is one normal N1 and the mass 3g. Okay. Understand. First we object and we see all the forces acting on it, not applied like forces by the object. Force act on the object. Okay, that's important. Okay. So for today's we'll end up this session. Next topic will be cover in the next session. Okay. Thank you everyone.